Yes, very good morning to Undal. May I audible?
Good morning, sir.
Yes,
Yes, sir. Good morning, sir.
Very good
good
morning.
morning, sir.
Morning.
Yeah,
Yeah,
very good.
my slides are visible.
Yes, sir.
No, sir.
Yes, sir.
Yes. Okay. Where we were stopped during the last class. Someone please remind me. Concerning today's class, I request 10 people to join with us. That might be the third batch, the third 20. Please join with us till the end. You please unmute your mic and please join with us till then. I think the name list is populating to everyone. From serial number 21 to 30, please join with us. 44, that is Gogol Kannan to Jayant. You please unmute your mic and please join with us till the end. Gogol, Haripriya, Hashvita, Yepan, you please join with us till the end. You please unmute your mic so that I can able to hear some information from your end.
Sir, till what
It
roll
will be
number,
better
sir?
to understand whether you are in line with the content or do you have any. If you have any doubts, then it is there might be a chance to get a conversation. Have you joined? Yes, you please unmute your mic and please join with us. No one unmuted.
Sir,
Yes, yes. Yes, this is what we have seen in the last class. During examination, that what are the things you have to perform. These are the contents you need to perform during examination. That is, you have to start from working principle, classification, layout, advantage, and then disadvantage. Under layout, you have to discuss about the various factors related to the environment and surroundings. That is, catchment area, water reservoir, head raise level, dam, gate wall, and penstock, surge tank, and waterway, water turbine, trap tube tail raise, and powerhouse. Powerhouse, the serial number 12 is powerhouse. And importantly, you have to discuss about the surge tank and the purpose of surge tank. And one important question will rise during the examination is what is meant by water hammer and how it is feasible to reduce the effect of water hammer during sudden stoppage at the power station. And that is why that is what we have provided a provision called surge tank. And these are the things which we have already discussed, and even we have disseminated one video also. And see, this is what the layout you have to perform during examination. And see, there are based on the hydroelectric power plants are classified in different ways during when we are concerning about the water flow. And it was classified into three. When it was concerned with the water head, it was classified into low head, medium head, and then high head. And concerning the loading type, it was classified into base load, peak load, peak load, and pumped storage plant for pick up the loads. And the run of river plants without pondage and with pondage, and the reservoir power plants has to be discussed. And I think these all the contents are available. Anyway, we are going to disseminate these these materials once the unit is over. You go ahead with these contents and prepare with the aid of the presentation. You collect these information and try to read it out. And see, this is what there are three different types of power plants, hydroelectric power plants are available. One is low head. The second one is medium, and the third one is the high head. when when the height is below 30 meters, that was classified as low head. And for this type of low head hydroelectric power plants, the dam constructions are essential, and there won't be any need for the surge tank, because the dam itself, it has some discharge provision for the surplus water. Therefore, there won't be any question for getting the sudden stoppage of water at the power plant. Therefore, there won't be any essential for providing the surge tank at the low head hydroelectric power plant. And concerning the medium head, this is what the low head. Just a minute. This is what the typical example for the low head hydroelectric power plant. There won't be any surge tank provided here. And the medium head hydroelectric power plants are classified with a height between the 30 meters and 300 meters. This height is differentiated from the text to text. Anyway, you please go ahead with this content. During the last class itself, I have given some height that was different. Here it was different. The author by author, the height varies. Here in the medium head hydroelectric power plant, a 4-bay is used for a medium head, and this is what the 4-bay, which is tapped with a river, and water is lead to the turbine via the penstock. And here also there is no need of providing the surge tank. And concerning the high height, when it was the height is beyond 300 meters, at that time we need to provide a surge tank. And this is what the high head hydroelectric power plant, which we were detailed during the last class. And there are 3 different types of turbines used in the various hydroelectric power plant. And the name of that particular turbine was Pelton, Francis, and then Kaplan. The 3 different types of turbines were used in the power plants now to convert the mechanical power into an electrical power, now to receive the water flow, now to receive the kinetic energy of the water, now to convert the mechanical energy. We are providing a structure, and that is what the Pelton wheel. And this is what about the 3 different types of hydroelectric power plants. And right. Yes, base load hydroelectric power plant. The load factor of this plant is high, and it is suitable for the constant load. And the without pontage and reservoir plants are used as base load plants. And concerning the peak loads, and this plant is suitable for peak load curve for the power system. And concerning the runoff river plants with pontage and reservoir plants used can be used as a peak load plants. And concerning the pump storage hydraulic power plants for the peak loads, there are 2 different types of pondages. One is upper head and the tailwater pond. And the water ponds are connected to each other with a pin stack. And during offload period, the surplus energy of the plant is utilized and pumping the lower head pond water to upper head pond. The extra water is used in the generate the energy at the peak loads. And the selection of hydroelectric power plant is very important. The site selection is very important. We'll discuss this in later presentation. And advantage and disadvantages are detailed in the last class. And this is what the energy demand and statistics of energy demand I'll explain one by one. And for concerning today's class, we will make a detailed note about the thermal power plant. And probably the coal might be the raw material for the thermal power plant. In order to understand the basic principles, we need to have a visit over the video lecture. You go ahead with this video lecture, and then I'll make a detailed note about the thermal power plant. This is what the block diagram. Now, to understand this thermal power plant, this has to be divided with 4 different types of layouts. that is coal and ash circuit, and air and flue gas circuit, feed water and steam circuit, and cooling tower circuit. Anyway, I'll disseminate these information one by one. There are various accessories related to this thermal power plant has to be understandable by this video. You see the video, and then I'll disseminate the contents related to thermal power plant.
Thermal power plants help meet almost half
It
of
is
the world's
audible.
power
The
demand.
video content is audible.
Yes, sir.
Yes.
Yes, sir.
Yes. Yes. Okay. Is see will yes. Have you everyone watched this video? Okay. Anyway, we'll refresh some
Yes,
some
sir.
other contents. Yes. Yes. Anyone use please share with the current affairs. What was the current affair? What was the headlines in Hindu today, or any other current affairs? Anyway, I'll start with the current affair. See, during the first wave, now to make it double, the first wave took around 3 months. But in the case of the second wave, we were in today's statistics, we were elevated to 3 lakh. But concerning the 2 lakh, from 1 lakh to 2 lakhs, within 10 days it was elevated. See, when it was in the case of first wave, it took around 3 months, but during the second wave, it is very hard to share. Within 10 days, it was elevated into double. It was converted into double, and therefore, very cautious measures are essential now to pass these strange days. So be aware when you are moving outside. Better you stay in your home, and there is no other way. Please follow the instruction given by the state and central government, and be safe. And any other current affairs? Any other current affairs?
Sir, it was related to the first 3 months power production of India, which increased to 141 gigawatt, which was last year only 134 gigawatts. So increase of 6.1 gigawatt production, and the
Earlier,
contribution of
earlier it was 128. Earlier it
what
was
134 gigawatt.
okay. At
First three
present,
months of 2020, and
okay,
in the
okay.
present it is 141.
141. Very good.
And the
Gigawatt.
contribution of renewable energy was 37%.
Okay. When yes, yes, very good. Who's this? Who's this?
Sir Subham.
Sugam. Okay, good. Very good. Very good. The current app is in line with the subject. In line with the subject. Very good. Very good. Anyway, since your friend talking about the first 3 months production in the India, and we have to be very aware with the units. Jiha, what was the what is mean by what? What the four different units you have to remember with I'll share. Yes. Please make a note of this unit conversions. 1 joule is equal to 1 Newton meter. 1 joule is equal to 1 Newton meter. Is okay. Anyone? We request anyone to share any other current affair. Any other current affairs? If anyone watching T20, 2020, go ahead with the yesterday's match. No one is very good. It was nice.
Sir, what you are asking, sir?
What happened in yesterday's match?
Oh, yesterday, like CSK won, sir.
CSK.
KKR lost.
CSK won the mistake.
Okay, I think it was in Mumbai. What happened in Chennai? Chennai, there are two different.
Chennai versus Kolkata, it was, sir, and Chennai won. And
Okay,
another match was between Punjab and Hyderabad. So Hyderabad won that match.
okay. Okay, fine. Anyway, in line in connection with the headlines with the Hindu, it is very sad that 24 COVID-19 patients in Nasik die without oxygen as gas leaks. See, when there is an any mishappening, that what we have to understand, we need to learn from that mistakes, and it won't happen again. And we can even this particular accidents also we can learn what was the mechanical failure happened in the system. In that way, we need to approach and we need to learn a lot, and this will give you an insight for a newer invention, and you please aware about the happenings in and around you. And concerning this unit conversion, the joule is equal to newton meter, watt newton meter per second, or it might be a joule per second, pascal newton meter per newton per meter square. And concerning the newton, 1 newton is equal to 1 kg meter per second square. And what was the relation between the mass and weight? With the aid of mass and weight, we can relate this unit, the last unit. What is the relation between mass and weight? You are trying to purchase a 25 kg rice bag, whether it might be a weight or it might be a mass. Or you are trying to purchase 2 kgs of brinjal, or it might be a onion, or whatever it may be. Whether it might be a mass or it might be a weight, or you are trying to get your weighing your information in the weighing machine. It shows some 60 or 70 kg, whether it might be a mass or it might be a weight. Someone, yes, it was, yes, already time is going, please. Yes, go ahead here. Someone, what was the relation between mass and weight? Yes, Ankit. Ankit, any idea?
So weight is mass is actually a property of a body, but the weight is actually the attraction forces between two bodies. Like we are standing on Earth, so our weight is equal to mass times the gravity of Earth. Similarly, we will be on Moon, and our weight will be like mass times gravity of Moon. So weight is like attractive force that is like attracted by another body.
Yes, inclusion of attractive force in the mass is equivalent to weight, right?
Yes.
Okay, in the example, that 25 kg rice bag, whether it might be mass or it is a weight.
What's that?
Master.
Mass. Okay, you are trying to get your information the weighing machine. Let it be a 50 kg, whether it might be a mass or it is a weight. That is also mass. That is also mass. As detailed by Ankit, what was the we know the average pulling force, that is gravity in the Earth is 9.81 meter per second square, meter per second square. What is the pulling force of Moon? Anyone knows? What was the pulling force of moon?
1/6 of Earth.
Pardon?
1/5 of, sir, like the what
One
gravity
one
g by
fifth.
5 of like what we,
3/5, sir.
Say the exact value.
like if we are weighing 60 kg here, sir, we will be weighing around 1/5 of like 12 kg on like on 12 Newton, sorry.
See, a 100 kg person, 100 kg person in Earth having a weight of 981 Newton. Therefore, it has to be multiplied with 9.81.
160 around.
Yes, very good. Very good. Josana is right. 1.6 meter per second square is the pulling force of moon. 160 Newton might be the weight of a person who is having 100 kg in air. Yes. Therefore, see here the kg meter per second square is 1 Newton. Sometime kilogram force can be converted with the aid of Newton is 9.81 Newton. Therefore, see, this is what the hydroelectric power plant, the P, that is the power which is developed during the supply of water. W might be the specific weight of water. The unit is kg per meter cube, and q is the rate of flow of water in meter cube per second. And what happens, this meter cube will cancel, and the rest is kg per second, the height in meters. And therefore what happens, kg meter per second. The conversion of kg into Newton is we are adding 9.81, therefore that was converted into Newton, therefore Newton meter per second. Here the unit is Newton meter per second. Therefore, we can convert this Newton meter per second into watt, and in order to have a kilowatt, we are adding here 10 power minus 3. This is what the power in hydroelectric power plant. Do you have any doubts with this unit conversions? Do you have any doubts with this unit conversion? Shall I go ahead with thermal power plant? Kg per meter cube. Here meter cube per second. Meter cube will cancel. Therefore, we have kg second. Here H has meter. Therefore, kg meter per second. That kg is converted into Newton with the aid of 9.81. Therefore, Newton meter per second. The Newton meter per second is nothing but watt. And in order to have a kilowatt, we are adding 10 power minus 3. That is what the power in the hydroelectric power plant. This theory I'll detail one by one in the subsequent class. And see, this is what the fuel and ash. There are 4 different circuits we need to understand, and we'll go through one by one. This is what the circuit, and see, this is what the structure. The coal from the mine is stored in coal storage yard. Therefore, what we need to do, we need to get the coals from the coal mines, that has been loaded in some transportation, and that was unloaded in nearer to the boiler, nearer to the plant. And then we need to prepare the coal, because when we are getting the coal from the coal mines, the size would be different. Therefore, in order to make it into the boilers, we need to prepare the coals. The size has to be very minimal, and then the sized coal has to be sent to the coal storage area. We need to store the coals, and then through the handling equipments, whether it might be probably it might be the conveyors, belt conveyors are used as an handling device in the boilers in the power plants. And therefore the coal has to be handled from the storage area into the boiler. Once we are converted the coal into ash, the output we are trying to, what we are trying to get, we are trying to get the heat source, heat energy from the coal. When it was burning, we are trying to receive the heat that was converted into steam with the aid of water. And once it was burned, what happened, we'll get ash. Then therefore, as we are handled the coal. Similarly, we need to handle the ash and then ash storage, and it has to send out. And be conscious while handling with the ash. See, in India, Indian coal contains about 40% of the ash, and concerning the 100 megawatt capacity power plant produces 25 tons of hot ash per hour, and therefore sufficient space near the power plant is essential, and to dispose such large quantity of the hot uh, ash. And this is what the first circuit. And concerning the second circuit, the air and flue gas circuit. We are trying to collect the atmospheric air with the aid of forced draft fan. We are getting the atmospheric air, and we are sending that to into air preheater. What happens in air preheater? Here the air preheater is surrounded by the flue gas, and the flue from the heat energy, we are trying to preheat the air before it enters into the boiler. Then the flue gas is sent to the superheater. In the superheater, the low pressure and low temperature steam is converted into high temperature and high pressure steam. Usually that is called as superheated steam. In order to get the motion in the turbine, in order to actuate the prime movers, the steam should be superheated steams. Therefore, it has to be elevated into high pressure and high temperature. That was with the aid of the heat energy in the flue gas we are utilizing in the superheater, and then it was passed to the economizer. As I said earlier, the economizer is an arrangement which preheats the water. When the waters before entering into boiler, it was preheated. Then it was sent to the air preheater. Here, air preheater is a structure. It was surrounded by the flue gas, and the flue gas has some heat energy. That heat energy is sent into the air, which was sent to the boiler. Yeah, when it was entering into the boiler, it was with some amount of heat energy. That heat energy is utilized from the flue gas, and then through the dust collector, it was sent to the atmosphere. We are providing chimney, and through some forced draft fan, it was sent to the atmosphere. Before it was sent to the atmosphere, we need to collect the dust. Through the dust collectors, it was collected, and this was the second circuit in the thermal power plant. And the feed water and steam flow circuit. And if do you have any doubts with this two circuits, coal coal and ash circuit and air and flue gas circuit? Shall I move ahead? Shall I move ahead with the other two circuits? Anyone?
Yes,
Anyone?
sir.
Yes,
Yes.
sir.
Okay.
Yes, sir.
Yes. Yes. The third circuit is feed water and steam flow circuit. Feed water and steam flow circuit. And what happened? This is what the feed water and steam flow circuit. The high pressure steam generated in the boiler is supplied to the steam turbine, and therefore the work is done by the expansion of the steam in the turbine. The pressure of the steam is reduced, and the function of the steam turbine is convert the heat energy in the steam into rotational power at the shaft on which the turbine is supported. Where in this portion, and the rotational speed of the turbine shaft set by the frequency of the electricity supply, and is 3000 revolution per minute, and corresponding to an alternating electrical supply of probably 50 hits. And we have the electric generator. The electrical generator is directly coupled to the turbine, and it converts the mechanical energy and the mechanical energy of the turbine shaft into an electrical energy, and it consists of the electrical windings. So one is mounted on the turbine shaft rotating within is called rotor. The other is arranged as a rotor fixed to the floor is called stator. We have rotor and we have stator. The relative motion of rotor and stator generates the electricity of 11,000 watts. And we have condenser. The expansion of the low pressure steam from the turbine passes to the condenser, where it is condensed to the water by cooling. And the condenser is large vessel containing a number of brass tubes, and the cold water is circulated through these tubes continuously for condensing the steam flowing outside the surface of the turbine. This is what we have seen at the end of the video. And the condensate leaving the condenser is the first heated in the low pressure water heater by using the steam taken from the low pressure extraction point. And the feed water here, the feed water is supplied to the feed pump by an external source to compensate the loss. And we have the hot well, and the feed water is the pressurized water is sent to the economizer through the pump. It was elevated the pressure, and through the economizer the water is sent to the boiler. And here what we are converting the we are trying to get the heat energy of the flue gas, and then water is preheated and it was sent to the boilers, and then the steam is converted. The here from the boiler the output might be the steam. The steam is converted into super saturated or superheated steam with the aid of superheater, and the source of heat energy in the superheater as well as in the economizer is flue gas. And therefore the superheated steam is given to the turbine, as I already detailed, and the turbine, the energy is converted into the mechanical energy is converted into electrical energy. Then the steam is sent to the condenser, not to convert into a water, because water is also a raw material, and we need to circulate, we need to get the water back. And then we have the hot well. When it was reduced, and then we have the sources. Now to add the external water, we have the makeup to the feed water system, and this is what the circuit continues. And this is what the cooling water circuit. We have the condenser, and we have the cooling tower. We have the pump. What happens? The it condenses and it drops the temperature in the steam, and it converts the steam into water by circulating in the cooling tower. In the cooling tower, what happens? We are trying to sprinkle the steam, and here we have the water circulation. When it was surrounded by the sprinkled steam is surrounded by the water, what happens? It suddenly cooled and it converted into water, and then it was sent to the hot well. And therefore we need to put this four different circuit into one, and this is what the combined circuit. See, there are four different circuits, and here this is what the boiler. This is what the first circuit, coal and ash circuit. This is what the coal and ash circuit. The second one is air and flue gas circuit. This is what the air and flue gas circuit. And the third one is, this is what the feed water and steam circuit. This is what the feed water and steam circuit. And this is what the cooling water circuit. While putting together and combined this circuit, we can understand what is happening in the steam power plant, whether it might be a thermal power plant. And there are, do you have any doubts with these contents? Please have a notebook and please make a note of this power plants. This is what you are going to replicate in the answer script. And do you have any doubts with the thermal power plant? See what are the inputs in the for the boiler? What are the inputs and what was the output? From the past study, past dissemination, what was your understanding? What are the inputs of the boiler and what was the outputs? Anyway, we'll make a detailed note. There are three different inputs. One is air, the other one is cold, the other one is water. There are three different inputs and output. There are three different outputs. The air is converted into steam, coal is converted into flue gas, the water is converted into ash, and the coal might be converted into ash, and this three different input has to be optimized before it sent to the boiler. And there are three different outputs. We need to get the larger extent of outputs, and we need to make use of that outputs, and that is what we are doing with the superheater, economizer, and air preheater. And anyway, I'll explain this in the future class also. We'll explain this with the combined circuit. I'll explain, and advantage and disadvantage I'll disseminate in the subsequent class. Do you have any doubts with today's lecture? Any doubts? Any doubts? Any doubts? Google, do you have any doubt?
No, sir.
Yes, Google. See. We'll ask some puzzle. Google, unmute your mic. Google. Hashmita.
Yes, sir.
Yes, Hashmita. See, we'll ask one question. You unmute your mic. You are participating. You are participating in the running race. See, there is some puzzle. You are participating in running race. Assume you are participating in the running race. You are chasing the second person. What was your question?
Anything greater than second, maybe third, fourth.
You are chasing the second person. What was your question?
Yes, sir.
What was your question?
Maybe third.
How it would be third?
I don't know, sir.
You are chasing the second one. Maitreyan?
Sir, can you repeat the question, sir?
Yes, you are participating in the running race. There are few peoples, and you are trying to chase the second fastest person. What might be your position?
First, sir.
Yes, we think this is what usually we think, but we have already a first person. We are trying to chase the second. We are the second person. Yes, anyway, good attempt from Maitreyan. Yes, this is what we need. You are giving your presence, but you are not responding. Your active participation is essential. Maitreyan, it is. Are you getting my point? Maitreyan?
Yes, sir.
Yes, sir.
Okay, good. Anyway, tomorrow 10:30 we'll meet. If you have any doubts, you please make a note, and tomorrow you ask, we'll disseminate and we'll try to resolve those questions. Thank you. Tomorrow we'll meet during 10:30.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you, sir.